Hello and welcome to feedback for Chem 3x15 take-home test number 2. The first question asks you to apply Lipinski's rules to this hay fever drug terfenadine. It's worth 5 marks, so looking at the overall breakdown for this exam paper should take you roughly 6 minutes under exam conditions. So thinking back to our very first lecture together, Lipinski's rule of 5s lists ironically 4 criteria against which a potential drug can be evaluated to determine its oral bioavailability or drug likeness. These criteria are the molecular weight, the number of hydrogen bond donors and acceptors, and its partitioning coefficient log P. So to answer this question, we need to evaluate terfenadine against each of these 4 criteria. So molecular weight for terfenadine, value is just under 500, so we meet that criterion, and that's the first tick. To assess the number of hydrogen bond donors, Lipinski suggests we just count NHs and OHs in the structure. In terfenadine there are these 2 hydroxyl groups, 2 hydrogen bond donors. That's fewer than 5, so a second tick. Hydrogen bond acceptors, we're looking for nitrogens and oxygens, and we can see in the blue circles there are 3 of these in terfenadine, so that's a third criterion met. Finally, the partitioning coefficient, log P, which is given to us as 3.22, this is indeed below the stipulated maximum of 5. So in answering this question, we've considered what each of those criteria state, but also then whether or not terfenadine meets that criterion. So half a mark for recognizing what the criterion is in each case, half a mark for demonstrating how terfenadine meets it. Simply listing the 4 criteria and putting a tick next door to them is only going to get you half the available marks. Note that we still haven't quite finished answering the question, which goes on to ask us what our analysis tells us about the suitability of terfenadine as a drug. It doesn't tell us that terfenadine is a good drug, it doesn't tell us anything about how it's actually going to operate, but the key is up there in that orange box. It tells us about bioavailability or oral availability. It tells us that this drug has the right balance of hydrophilic and hydrophobic groups, or lipophilic and hydrophilic groups, to be readily absorbed and bioavailable when taken orally. That's the key thing. These rules are about the absorption or absorbability of a potential drug. Question 2, looking at the same drug, but now thinking about how we might make it. It's a synthesis-retrosynthesis question, and you need to apply all that you've learnt in this context. And read the whole question. The question tells you to show disconnections, to show synthons and functional group interconversions. There will be marks available for all of these things. So even if you can't get a perfect solution, apply the principles and get what credit you can. And as previously, for 6 marks, we're looking about 7 minutes under exam conditions. Before you start piecing together a retrosynthesis, it's worth looking at your target molecule in the context of the pieces you're going to use to build it. So color coding, as I've just done here, we can see that the left-hand part of terfenadine must arise from this ester. Importantly, we've got some sort of change reaction that needs to happen here to take that ester to the tertiary alcohol in the product, and we're going to alkylate that nitrogen to form this carbon-nitrogen bond here. Conveniently, second building block is this dichloro compound, and it's well set up. We've got a potential acceptor synthon here that could react nicely with that nitrogen to form that carbon-nitrogen bond. At the other end, an acid chloride, that's also a pretty good acceptor, which could react with this aromatic nucleophile. So the third piece of the molecule clearly comes from this tert-butyl benzene. We're looking to form a carbon-carbon bond from our aromatic ring system to this acyl group here. But paying close attention, the oxidation state of that position is changed. We have a carbonyl group in the starting material, an acid chloride. We've got an alcohol in the product there, so there's some sort of reductive transformation involved. Lots to be thinking about, but also heaps of information, lots of clues in the question. So use them all, take advantage of every bit of information that you are given. This is the answer that I've come up with. I'll give you time to think about and look at that. But overall, I'm starting with the FGI, the secondary alcohol here to the ketone down here. Then thinking about the first disconnection, we're going to break that carbon-nitrogen bond in the retrosynthetic sense, get that amine out of the molecule. Showing our fat arrow again. The synthons. Here's our acceptor synthon, positive charge on that carbon. Here's our donor synthon, negative charge on that nitrogen. Really only makes sense to put the plus and the minus that way around. Nitrogen's going to have a lone pair, that's going to be a good nucleophile, it's always going to be a donor synthon. The acceptor synthon over here means we can take advantage of the alkyl halide that we know we have in one of our starting materials. So draw the synthons and then draw the reagents that correspond to them. So this secondary amine for this donor synthon, this alkyl chloride for the acceptor synthon. Continuing down the left here, from the tertiary alcohol we can envisage disconnecting both these phenyl groups to take us back to this sort of a synthon, which in fact corresponds directly to our starting material number 5, because of course from the ester, reaction with one equivalent of phenyl magnesium bromide, our donor here, will take us to the aldehyde, which reacts quickly with a second equivalent to give the tertiary alcohol. Over the other side, next disconnection is through that carbon-carbon bond, acylation reaction, and that takes us back to synthons that correspond conveniently to both of our other starting materials. This acceptor synthon here, this acyl synthon, acyl cation, corresponds to the acid chloride, and this donor synthon, negative charge density on that carbon of the aromatic ring system, is how we would expect tert-butyl-benzene to react as a potential nucleophile in an acylation reaction. So there we have an overall retrosynthesis. You might choose to do a couple of the steps in a slightly different order, but overall that's the sort of sequence you need to be thinking about. In terms of mark allocation for a question like this, well, I'm offering half a mark for each good disconnection or FGI. You can even get half a mark for your first fat arrow here. So not all the way down, but for showing me one of those retrosynthetic arrows, there's half a mark on offer there. Half a mark for recognizing this as an FGI. Here's a good disconnection, and showing each of your synthons gets you half a mark. Showing the reagents that correspond to those synthons, half a mark each. We've got more disconnections here, down to these synthons, and over here, down to these two synthons. Then an overall mark for the overall quality and style of your retrosynthesis. Does it make coherent chemical sense? Have you done the steps in the most sensible order? Is it nicely laid out and easy to follow? So the last mark of the 6 is available for those general pointers. If you add things up there, you'll see that actually we've got slightly more than 6 marks on offer. So if you missed a synthon or you dropped a disconnection somewhere along the line, you can still gain full credit here. So these half marks through here are on offer through up to a maximum of 5 total marks, plus the 1 overall mark to make a total out of 6. Final part of the question is to turn that retrosynthesis back around and put together a synthesis of terfenadine, bringing those different steps together. Again, read the question. Don't miss out on marks by missing out on a key part of the question. Question asks you down here to comment on issues of selectivity. There are 2 marks on offer for this, so don't miss out on those. Again, 6 marks worth. It's about 7 minutes in exam time. So putting up my overall synthesis, this is what I propose. Starting with that amino ester that we have, starting material number 5. Reacting with 2 equivalents of phenyl magnesium bromide, we get our Grignard addition to that carbonyl group. As I said a moment ago, the first equivalent does a substitution reaction effectively. Electrons up onto oxygen, back down again, kicking out a ethoxide. That resulting ketone, I think I said aldehyde on the previous slide, my apologies, can then react with a second equivalent of Grignard to give the alkoxide version of this alcohol, which is protonated on workup. I put the workup in brackets here because that's not essential information for your complete answer. The perfect answer will specify that there's aqueous workup, but you don't need to add that to get full credit for this question. Second reaction over here is the Friedel-Crafts acylation. Reacting this acid chloride with tert-butyl benzene, we need a Lewis acid catalyst, and again aqueous workup. Same conditions apply. Third step is a substitution reaction, bringing that nitrogen nucleophile to react with the primary alkyl halide. We're going to release HCl, that H and that Cl, so we need a base. An amine base is good, sterically hindered amine base, so that it doesn't interfere as a nucleophile in its own right. Although there are half a dozen different bases you could specify here. I like triethylamine, it's a pretty simple one. Final step in the sequence is the borohydride reduction of that ketone. Ketone needs to be reduced. Sodium borohydride is a great way to do that, and we're going to use aqueous workup. Now the mark allocations, which were hopping up ahead of time a moment ago, basically 1 mark for each step. So bringing the ester and the Grignard together, that's a mark. Combining these two guys under Friedel-Crafts conditions, making sure you specify a suitable catalyst. Could be aluminium chloride, could be iron trichloride, there are other possibilities there. 1 mark for bringing these two guys together with a suitable base, and a mark for our borohydride reduction of that ketone there to the secondary alcohol down here. So adding all that up, 1, 2, 3, 4, that's 4 marks of our total 6. The other 2 are for this question of selectivity. And there's heaps you could say here. For 2 marks, really, you need to identify 2 examples of selectivity and explain what's happening at each case. In that first step, the amine NH is potentially acidic. And with Grignard, probably going to be deprotonated. So you're looking to include a third equivalent of the phenylmagnesium bromide to ensure the outcome that you want. Your Friedel-Crafts reaction. The acid chloride you're using up here is also at the other end an alkyl chloride. So we're relying on the fact that the acyl position is more reactive to get selectivity, which is chemoselectivity here, for acylation in preference to alkylation. In that same reaction, there's a question of regioselectivity at the aromatic ring. Remember that an alkyl group is orthoparadirecting, but a great big alkyl group like this tert-butyl group is going to create quite a lot of steric bulk, so there'll be preference for the para position over the ortho alternative. This step, our coupling step, there's a question of chemoselectivity again, because our donor partner, we have a nucleophile at nitrogen which we want to react. We have a potential nucleophile at oxygen which might also react. But remember, of course, that oxygen is more electronegative than nitrogen, so nitrogen is more nucleophilic than oxygen, and we get the reaction proceeds as we would hope through the nitrogen rather than the oxygen. And you might consider the stereoselectivity in this last step. Although the stereochemistry is not specified, your product down here of course contains a stereogenic center, and potentially if you wanted to control that stereochemistry, then using an asymmetric reductant would allow you to do that. Choose 2 of these, identify the selectivity that's involved, chemo, regio, stereo, and comment on it. So half a mark for identifying it, half a mark for an intelligent comment. Let's wrap up there and see you again in a few weeks' time.